Okay, now members, welcome to the episodes of 2023 UACE, the paper Senior 6 did this year. So now, we are going to start with number 1. It was coming from proof by induction problems. And now if you want to see more about proof by induction, subscribe and then go to the playlists. You will see more about proof by inductions. There are many different answers there. So now, the first question was proof by induction that is equals to that. What we had to do is we had to first start by expanding this. So they are summing from 1 up to n. So you had to first remove the summation notation, even though you can handle it when the summation notation is also there. But for clarity, it's easier to handle it when you expand this into a series. So when r is 1, I have 1 squared plus the next integer is 2. We are squaring it. Next is 3 plus, we cannot complete all the integers, but we are telling us that we are ending at n. So plus n squared equals to the right hand side, which is the whole thing over 6. So that's the first part. Now we prove it's true for n equals to 1. Now for n equals 1, it means that we are taking the first one term. So our left hand side equals to 1 squared, which is 1. Then our right hand side, we just put in now n as 1, which clearly is going to give us a 1, because this is 6 divided by 6, which is 1. We can even try for n equals to 2. Our left hand side, we are taking now the first 2 terms, which will be 1 plus 4, which is 5. On our left hand side, we have now, where there is n, we are putting 2. Into now a 5. This is 6 divided by 6, which is 1, times 5 is also equal to 5. Next now step, we assume it's true for n equals to k. Now if it's true, we are just making an assumption. So we are putting, where there's n, we are putting k on the right and also on the left. So 1 squared. Now where there is n, I'm putting k equals to now this is what I have. Where there is n, just put k. Now I prove it's true for n equals to k plus 1. Now these are k terms. Now if I want k plus 1 term, I'm going to, on the k terms, these ones I'm going to add only 1 term like this. So we have it now. Now these are the k terms, but I'm adding 1 term. How do we add a term? You see that to get this from this to this, they're adding 1. From this to it, they're adding 1. So if I'm having this, the next term is going to be on the k, I add 1, then I square. Equals to, now here, where there is n, we put k plus. Okay, what we are having here, we are putting now on this, we are also, because this equals to this, so we are just going to add only 1 term. So we have k over 6 into, then plus what we have added this side. You are adding this side and this side, so this is what we are going to just add here, square. Then what we have is to simplify the right hand side. So it's that our LCM there is going to be 6. Here I have now plus 6 into now, which I can simplify, so that k plus 1 is common. Factorize it out. Here I'll be having 2k squared plus k, then plus 6 into k plus 1, our thing over a 6. So now what I'm going to do is I try to remember the whole of this is in there. What I'm going to do, I'm going to try to expand it. So now, right hand side equals 2 k plus 1 over 6 into now. This is going to be k plus 6k, 7k plus 6. Then all we had to do to factorize this, I have now. To factorize it, numbers I multiply, I get 12, I add, I get 7. That's, I think, 4 and 3. If you had to factorize it into that one. So now here, remember, our n was k plus 1. So if I make now k the subject, my n minus 1 will be equal to k. Now where there is k, we are putting n minus 1 into that. So instead this one is already. So where there is k, we put n minus 1 plus 1 over 6 into 2 3 into, that one is already. Sorry, this one is 2 into n minus 1 plus 2. So you can simplify it to n over 6 into 2n minus 2 plus 3 into n plus 1, which I can easily write as n over 6 into n plus 1, starting with this here. Then 2n plus 1, and so that is equaling to what we have already there. Then you conclude that therefore, since it's true for n equals 2, since it's true for n equals 1, 2, and k plus 1, then it's true for all positive integers. As simple as that. So, come to number 2. They gave us, number they are giving us y equals to mx plus c is a tangent to a curve 4x squared plus 3y squared equals to 12. They want us to show that c squared equals to 4 plus 3m squared. So this one, if it's a tangent, means that the y of the line satisfy the y of the curve they are giving us. So what we do is just get this and we substitute it in there. So if you do that, now I'm going to be having 4x squared plus now 3 into now mx plus c all squared equals to 12. Expanding 3 into, now this will be 2mcx plus c squared equals 2, okay, minus 12 equals to, so I bring everything on the left. Expanding up bracket there, I have now 4x squared plus 3 plus 6 mcx plus 3c squared minus 12 equals to 0, which I can make a quadratic as 4 3m squared x squared plus 0. Now this one is going to be my a, so that is a quadratic in terms of c. I mean in terms of x, this is my b, and all of this is my c. I know that for tangents, or raise the b squared is equal to 4ac. Now there, just substitute this b, put my b there. So my b is going to be 6mc the whole squared equals 2. Now I have my 4 and a and the c. 4 into now my a, which is 4 plus m plus 3 m squared into my c, which is 3 c squared minus 12. All that's left is just to expand and simplify. So this is going to give us, when I square this, I get my 36 m squared c squared equivalent to 4 into, this will be 4 times this will get 12c squared. 4 times this will get minus 48. This will get 9m squared c squared minus 36m squared. So you see, you have now 36m squared c squared equals 248c squared minus, if you get that to your calculator there, and we simplify there, we have a common figure, which is, when you get now 48 times 4, we get 192 plus this and this, 36 m squared c squared minus 4 times 36, which is 144 m squared. You see that this one is going with this. Now I choose to divide through by 48. So my 0 is going to be by 48, there you get c squared minus by 48 here you get 4 plus by 48 there you get so I think minus by 48 there you get 3m squared. If you make c the subject, you can see that c squared is 4 plus 3m squared, and that's the proof they want us